announcements. Hi, Jason. Did I wake you up? I have a mad dash to find your phone number. I thought I had it, but luckily you posted it in some board somewhere.
So the good news is that the reason I've had a crazy week is that we finally found a new place.
Oh, there's a bad news I hear.
Well, bad news is we have to have it ready to move in before this place gets bulldozed, which is going to start October 1st.
Okay.
So things are a little crazy right now.
I bet. Well, congratulations. Is there anything we can help you? Is there anyone who can help us? Or need volunteers? Or
I have plenty of volunteers right now. The biggest thing I'm looking for is if you know a general contractor or an architect.
A real-time architect, not a computer architect.
They have to be a Virginia registered architect.
Okay.
Yeah, Daniel Green, he's actually a LUG member.
Who?
Daniel Green?
No,
he's a contractor though.
His license is expired.
Oh. Okay. Well,
You give it a try, man.
Yeah, the bad news is we've had lots of leads, and most of them are either insanely busy right now because the economy has picked up a little bit, or because the economy had been lousy, they let their licenses lapse. Or actually have one architect who really, really wants to help us, but he's licensed in the UK.
That like 200 years ago would have been enough. Whoa. I don't know any real architects. I know a lot of computer architects, but no real architects. Okay.
a Mac power supply.
Has anybody seen the bear?
The bear?
Yeah, there's a bear here in Northern Virginia. I saw it a week ago Wednesday.
Oh, lots of bears where I live. There's a lot of Virginia.
This guy was about 200 pounds and he was doing about 30 miles an hour. He's running along the Soul Road at Wall Track.
Wow. Well, maybe that's where we need to go. Give me action. Yeah. So, well, I'm glad to see a lot of people. I was a little afraid since Greg was not going to show up, but this may not have been the biggest turnout. So welcome. My name is Peter Larsen. I'll sort of be the stand-in, I think, a little bit for Greg, since he's not doing all the announcements. I see some new faces. Are there anyone who has never been to a NOVALUG meeting here? Well, welcome. You're most welcome. So we meet once a month, every second Saturday. Where we meet is really up in the air right now because NOVALUG has gracefully let us in, but then we should get building, we should get out. So we're still trying to figure out where that needs to be. If you have any companies that has space to sponsor, like a meeting on a Saturday, that would be great. We have tried to meet other times, but as Greg usually says, by the time he gets all the input back, Saturday always wins. So. Any other comments before I really get started here? Nope. Good. So what I'm going to talk about is a little atypical, because what I'm really focused on today is development. Not as much administrative, but we do have time to spare afterwards. So this is the talk I'm going to give next week, or next weekend, at the Southeast Linux Fest down in North Carolina. You're graceful enough to allow me to get in as one of the speakers. So what I'm trying to do is to focus extremely on the guys that make the system administration guys have a job. Right? Without development, we wouldn't have the software we work on. And to me, system administration a lot of times is about enablement of that group to actually do their deliverables, so we can all get our cool websites up and running and so on. That doesn't mean that as an administrator, there's not an overlap. And sometimes I need to fast get something up and running. But I'm really going to focus on the sides of this that deals with development. I am going to show you very little bit of development today. Don't worry, it is not going to, make you go, I have no clue what this is all about. I want you to get an idea of what a developer goes through. Are you trying to see them? Okay. But other than that, there is an architecture behind this. So if you are very interested in what we call Linux containers, I will be happy to, after I go through the normal little run that I have here, this will take about 50 minutes. I'll be happy to go and actually try to open up the doors behind the scenes and show how things work and what containers really are and all that stuff. So, who here has heard about OpenShift? It's been around for about 2 years. So there's a little bit of interest there. So OpenShift was an experiment from Red Hat that went out and said, okay, we got this idea, but we got to really try it out in the open. We can't really do it as an internal Red Hat, like a traditional development project. So 2.5 years ago, Red Hat decided to sponsor the initial trial out in the open cloud. And while it wasn't open source initially, we created a hosted solution where everyone, meaning preferable developers, would go on and sign up for a free account and get free resources available in exchange for feedback. And we get feedback. So the feedback was all a matter of how can we make this better, how can we extend it, how can we, why don't we do this way instead of that way? And that was such a big success that which we kind of knew what would happen once it was a success. We made an open source project out of it. That's what we call Origin today. So Origin is a source code behind the scene of what OpenShift has in public today, and that's still around. Anyone can still sign up, get an account that allows you to deploy your own code or someone else's code and run your own web service in the cloud, in the public cloud, free. Granted, it's not, and you can't get a Google in the sense of needing terabytes of data. It's a limited account, but you can certainly get a taste for it. And it's been with such a big success, you can even add or pay, just like any other web provider, for additional resources. Now, if you are a contributor, you don't have to pay. You usually just need to send an email to the right person and you'll get more resources. So it's the way we always work at Red Hat is we enable the community. So if you're going out to enable and you're pushing back code to the community, making the world better for everyone else, we pay you back by giving you resources. This works. If it doesn't, then I'll just use the keyboard. I'll use the keyboard. This will not work. This is what happens when it doesn't. So, from a developer perspective, what do we go to create software today? Well, I wish it was so easy to say, hey, I've got the best cool development idea today. If I just make the software do X, everything would work. Like, I would get coffee early in the morning, bagels would be ready, and everyone else in the world would be happy. If I just did my idea, and I can start coding right away, and things are fine. But the problem is that using my code by itself, I need resources. Like I need some servers somewhere. I may have them in my house. But what if my idea is, well, I need to write this Python code. But I have no clue about how Python's integration with Apache works. How does it actually talk to a database? How do I even set up a database that works? Because I'm a developer, primarily. I may be running a code, but this monster called Linux doesn't work. And often when I see people screaming for help, it's usually developers saying, none of what I've tried works, and I've fought for it for days or for hours, and it's frustrating. I can't even log in, or the accounts don't work. Let me disable all the security stuff, and it maybe work all of a sudden, quote unquote, work, right? Because just because I can log in doesn't it really working like this. Anyone in the world can log in. So I have all these additional things I need to know about. I have to know about, in many cases, how to install the others. As a developer, while this has become extremely easy, and I remember trying to install Linux 10 years ago. It wasn't easy. even back then, I'd say, well, there's an installer now. Yeah, well, if everything was lined up and then so an installer worked. I mean, I started 20 years ago, but there was no installer. That was even worse. But it's become easier. But there's all these questions being asked that as a developer, I may not know about. I mean, how do I know what packages I need? What are development libraries? What is the consequence of installing this versus that? There's all these system admin things that I need to know about in an OS installer, and they impact me for when I actually want to do my code development. I also need a place to actually run all my code. I mean, just the OS by itself doesn't do much. At the very least, I need the interpreters for the languages, or the compilers for the languages I choose. But very often, that's not enough. If I'm anyone doing a web application today, it doesn't matter what language. You have a framework to use. I'm not creating my own. Listen to that poll for requests, look for the headers correctly. All that is already implemented now. Most of us, when we do a web page, it's like creating a very small little package or object that just extends existing information, and presto, I have my own code as a web service. But I need that framework implemented. I need it integrated into a web server. I need to start it correctly. I need to stop correctly. All of that stuff needs to be set up. Now, if I've done that 10 times before, that's maybe not as a big of a deal. But then when I am a developer going to a company that has this huge organization and that has all these administrators, security folks, they're going to look at it and go, you can't do that. Because what you're doing is not secure, it doesn't fulfill our requirements. You need to implement all these special requirements that I never heard about before as a developer. I really never cared about how I fulfill certain government requirements or security guidelines, because all I really cared about was what my code worked. So this thing can be quite complex. And a lot of stuff as an administrator, that is what we fight with, is how can we make this work in that environment with all those specifications? How can we make sure that everything is secure? And there's tons of different frameworks. I did say ETs, etc., but there are a million out there, depending on what I want to do. And as I said, once you have it up, I need to configure it. I need to get my database connections. I've got to have connectivity to maybe Twitter or everything else in the world that I need to use in my cool application work. And then I can start my own code. Literally, that process can be not only frustrating, but it can be time-consuming, and if you're lucky, it may just take you a couple of days. If you've done it before, you may be down to hours, but in that case, again, as I said, in most cases, that just works for your internal development. Once you want to go, if this became a big success, how do you deploy it? How do you run this out in a web application to actually safety work? I mean, if you just want to do a little home server, doesn't do the world much good. So this process in companies are taking not days, not weeks, but months. I mean, I have some horror stories from some people I've talked to in government where they're talking about almost a 2-year process before they come. And it is if you look over time, and the study's done, what has really happened since we started our waterfall and all that is not only is this still the focus, but our waterfall no longer works within this idea of, I got to speed this up, because before I can go down there, I need to know all my requirements. Right? Who knows all our requirements before we start coding today?
That's a good question.
I know. Nobody. Well, because it takes time. Those requirements change. Right? What was good today is not good in months from now. We've got to be flexible. Right? Things will change. Right? So if I start defining something, and I know it takes 5 months to get down here, well, I know that everything has changed around. And if you look at companies like the big ones out there, like Facebook or Twitter, well, they go to this idea phase to production. I mean, not only start coding, but to production many times a day. And that's because they use methodologies like a little bit about what I'm showing in a moment. So once you get started, I got my server up, I can start coding. Is that enough? Well, not really, because if I do complex code other than outside of basic hello, I got to be able to build something for to deployment consistently. I need to make sure that maybe I have hundreds of source code files. Maybe I depend on all of these additional projects, which in most cases I will do, on the libraries, and I need to make sure when I build that I have all of those in the right versions, that I can control changes, and even more so, make sure I get the right versions of them so I don't get stuff that is incompatible with the code base that I'm going to do. That's called build system. Got to set that up. In most cases, in open source, I would probably use a place like GitHub to say this is where I keep my secret source code in the public, because that's no secret, right? But we have a central repository for setting up, but I may also have to do this outside GitHub. I may say, well, I can't do this because I'm actually working for my employer. I need a place to put all and manage all my code. Some provider places, and they should have a complete budget and all. You can't be using shared resources. You got to set all that up on your own. And of course, which we all forget, well, how do I know my code works? If I want to do this structured and just say, oh, I got my page up, well, I got to test, in particular when the code starts being complicated. If I don't define the business case, the use cases for my testing to be automatically run when I do my build, then I really don't know if I'm doing all the stuff that I'm supposed to do. Or even worse, if I'm not the only one building, which is most open source projects I don't want to be. I will start with the idea and push it out there as the one person, but the whole idea is to attract more people to start contributing. If I can't have a way of telling whether all my code is compliant with what we aimed at, or an easy way to tell whether this build was a successful build, and is there any errors in the code? Did anyone make a buffer override scenarios? Is there a specific use case that we didn't take care of? Well, that's what the test scenario is all about. And getting them run as part of my build is part of the issue. So this is where containers come from. And I'm going to deal with them right now at a very, very high level. I'm not going to go into the weeds of how these works and things work. But this is the benefits from a container-based environment. So a container is nothing more than a template, a known template of the system configuration. That allows me to instantiate, meaning set up something to run in seconds based on that template. No longer do I need to go out and know what needs to go in there, and package this and all that. All I need to say is this template creates my PHP environment that I want to use. That's it. Comes out of the box, all my PHP works. Another good thing about having a template is that if I have more than one project that all uses the same framework, when that template updates, somewhere, maybe not by me, but some smart system admin, all I need to do is apply that update once, and all my instances have changed at once. So a new patch comes down, a new CD was applied, a new security fix, and I can fix them all without knowing. All I need to do is apply that update to my template.
How does it compare to Chef Puppet for deployments?
So Chef Puppet requires me to have a central repository somewhere where you can retrieve all that stuff from in the right version. So for instance, your RPM base, you need to have a place where you update all those RPMs first, and then you can run your Puppet scripts and Chef scripts and all that stuff. Or if you're very smart, you can set them up to spawn off another job that downloads them and updates them essential thing, and then they start pushing them out to individual boxes. This is a template in this case is a single file. If you look at Docker, which is not an OpenShift today, but is a single file that you just plug in. And actually, it goes out to the central repository, downloads that binary, and you're done. It is all managed on a binary level. It's a lot simpler than a virtual machine. I don't have an OS to maintain. This actually runs on my own OS. It does implement a new OS. It just implements a small little world that is isolated, that is running completely isolated within my OS. So if it blows up, it only blows up that one container. If my code does something very, very bad and crashes the server, it only crashes that little container, not the whole server. If it gets attacked, it's only that little container that gets attacked. Can't attack anything else outside. And in that sense, security is a at the level, and there are some people that argue that it might even be more secure. I'm not sure I totally buy that, but the security-wise, you're not getting anything extra from putting it on. Extremely high lightweight. So one of the things is if you're running a hypervisor today, let's say you have an 8 GB box at home and you're running, let's say 4 VMs on them because you have 4 things running, you can easily double, if not quadruple that number with containers on the same hardware. Because I'm not wasting anything on additional OSs or additional hot overheads that I'm not using. And even better, I can actually, if one app is only using, let's say, 200 megs of memory, that additional memory that may have been available for the container can be used by someone else. I mean, I have a global pool of memory in addition to ship. This is the only architecture slide I brought in this depth. But this is a little bit about how what OpenShift looks like behind the scene, and there's a lot of stuff on here, and all the flux needs to be adjusted looks like. So sorry about that. So what we're seeing here, everyone see my little dot? Okay. So within OpenShift, we have 2 types of servers. We have what's called a broker and something called a node. The broker is nothing but a manager. What it does is it enables you to say, I need some resources, give them to me. Or I need to change the resources, or who can access them, etc. It controls all the repository stuff and all that. The node is what does all the work. The node is where your code goes to be executed. And nodes are divided into what we call gears. And gears in OpenShift speak is the container. So gears are implemented in a way that they are completely isolated from the rest of the elements. So we use SSLinux, we use C groups, we use audio spaces to completely isolate. So when I log on to the gear, I can only see my own processes. I have limited disk space. I can't see anyone else's stuff running on there. I can't even see their ports or anything else. I can only see my own stuff. And if my app goes down or gets hacked because of that, there's no access to anything else. So they are fully isolated. Each gear, and this is where this is getting a little tough. These puzzle pieces are it's what we call a cartridge. So the cartridge is templates. In OpenShift speaks, this is where we define what does my gear do? What does my server do? So this could be a JBoss, it says here, but it could be PHP, it could be a Python, Ruby, Node.js, pretty much, it could Python. If it runs in Linux, it can run in a gear. It's not even true anymore. If it can run on .NET, it can run in a gear. So we have to have a .NET server in the community that does C# stuff easily. It runs in a straight on a Windows box, but runs within the same paradigm. So the gear can have what we call add-on gears functionality. So PHP, well, I need a database, so I add on the database feature to it. I need build management, I add on Jenkins to it. And it modifies it by adding the connectors, or even when I send the database, it will deploy the database into it. Set it up, configure it, make it ready, get the username password. I can start using it out of the box. Don't have to do anything. So as you see here, in this case, the MySQL is on, and there's also a build management part here. And what you can't see there is that that's where the code resides. So my gear contains my whole repository of code. It contains a pre-configured, already set up application server for my code. Whatever extra resources that I need, ready to go, I can start coding right away. So a normal developer will start by first sending a command in and says, I need a new gear. Once they have done that, the next step is, hey, put in my code into the gear. Then it's not running. This process here takes, if everything goes well, less than 10 seconds, including a database. That should wait. And all of this down here is more or less marketing, but basically this is RHEL, CentOS, Fedora, doesn't matter. As long as it's one of those Linux where we have the repository for which is ready, it will run. Can you tweak around and make it run on the SUSE or Ubuntu? Sure. But you probably can't follow the 100% of the guide from there to do that. But the code behind OpenShift is Python. It can be made to one language. Any questions about this? This is the only architecture I have planned to talk about right now. And the next couple of slides is just to go through some examples before I show you live how things work. Nope. Okay. So I brought a white slide. I'll listen to this because I couldn't get the files to match up. Yes?
Just thinking out loud, how would one on the command line access what's in one of these containers? So let's say I want to interact with how do I do that?
So everything goes through Git. So the way you generally interact is to tell it what code to use. So all I need to do, and examples in a moment is going to show that, is like any other source control, I push in my code to, I have, it allows you to have multiple repositories, right? You can have local, global, all that stuff. So by default, the first thing that happens is it will clone that repository to the local box. So I just CD into the directory on my own box, do my changes to on my local machine, I check in the code, and I hit push, basically normal synchronization. That gets it into OpenShift and we're done. Now, there is a command line tool that allows you to do a lot more, like debugging, looking at log files, or even SSH into the gear to look around. All that's available too. I brought this up because I wanted to show you there are 3 different versions of OpenShift out there. I already talked about this, the Open Online, where we started at Red Hat. That became the open source project. Once that was done, basically now this is feeding the OpenShift Online. Some new features coming out in the community, and it's up very, very fast on the online side. This is basically a test bed for Red Hat. New ideas, new concepts, here first. We have more than 1.5 million apps running here. If something ain't working, it needs to be more robust. We can't do a better QA internally. We can't run that much on our QA. There's also a product that is behind this, which, of course, costs money and has ported and all the stuff with Rail. We happen to help you out with that stuff too. This is usually quite far behind the original, because it goes to the whole QA, how to place, and make sure we support stuff going forward. That said, this is where I see a lot of interest because this allows you once portal in your own cloud internally. And really notice that I'm trying to avoid the word cloud because it doesn't mean anything to anyone. Officially, this is called PaaS, Platform as a Service. Yes?
I should point out one thing, by the way, that if you're looking for really cheap Linux hosting, that online is actually the cheapest. I use AWS, DigitalOcean, and online, and AWS is the most expensive. Of course, that's still not a whole lot, but DigitalOcean, you can have a small instance for a few dollars a month. For OpenShift online, it's less than a few dollars a month. So it's definitely worth experimenting with it just for the knowledge, as well as the hosting.
I agree. I mean, it's getting started. You need an email address, that's it. Anyone can get what we call 3 gears. Gears is the containers. So without a database, you can have 3 applications running, depending on how you set things up. That may include a database, may not. I can get into those details later. So this is the commands. And I'm not talking about how to use this in a browser because that is possible too. But I'm a developer here and I want to get started with my cool PHP app that I got an idea of. And I'm way behind the times on the PHP programs there. Well, this is the command to create a gear that is based on PHP with a MySQL backend. Now I have the versions number on there because in this case, my OpenShift supports multiple versions of PHP and multiple versions of MySQL. Which in many cases as well, I got this from GitHub. I found this cool project out there, but they based it on this particular version of Python, PHP, whatever. This allows you to get an environment up to that, and not just the latest and greatest and all the stuff I have to do code changes and all that stuff. So by running this, not only did I get a gear, but I got all the pre-deployed code to my local machine already. It did a clone. Now, what code would that be? Because I didn't tell you anything about any code out there. Like, Well, if we don't tell it about code, it creates a very static HTML page or index HTML that fits your button. That's it. We don't want to make up an app that comes out with an error when you access the first time. We want to make sure that there's something. I can add a parameter up there called from code and give it a GitHub reference, for instance, or to any other Git repository reference, and it will instantiate the gear with that code instead, which means you don't start from a blank slate. But in this case, let's just start from a blank slate. Go in and you edit and add some files. You went into the directory, you just start your own local machine, do your cool stuff with PHP. When you're done, you run git add. If you add files, you have to use that. If you did not add any files, you just need to commit flag. This is the standard. Any developer that doesn't know how source control management works hasn't done development for me. So this is a fact of life. It saves your butt when you make a mistake. If you're working with many, many people, you can't get around this. There's really no way of doing software development without the source control. The new thing may be the push. If you're not a contributor to an open source project, you've not experienced the idea of taking what you have done and merge that back into, or push it back up to the upstream project. That is what Git push does. So all it does is to make sure that my local repository is now in sync with the global repository of the Git. Since I created it, I own it. By doing that, everything gets built, everything gets compiled, and all I need to do is go to the browser and unload it. I'm going to show this live and how I did that. That's it. That's the steps. So that my overhead is really only that one command up here. Everything else I would have done otherwise, maybe except the push. I keep hitting the button here if it doesn't work. So, for more advanced builds, anyone who here is familiar with Jenkins? So Jenkins is a build control system that has a quite interesting and long history behind it. But when we do software builds, we usually need to go through a set of steps to get there. We always have to build in a certain way, make sure we build the same way every time. But we also want to make sure that when we have built a project, what happened? I mean, what is the state of my project? Did everyone fulfill, we're going to have 10 collaborators, did everyone use the variable name policies that we already agreed to? Did all my test scenarios run well? Are there any other known artifacts that we didn't cover already that we knew up front? And basically, the build process can run not only compile my code, but verify that my code is compliant with all our agreements. I mean, I get a nice little report on it. To publish that report onto my project space, and now I have a nightly, let's say I can run that nightly, and I have a nightly build status that says, hey, we got this file. This is where the code is. And if you're in a company, and you have a bar squeezing down the neck, this is the page you can go to and see exactly where you are, your project is, and see whether you're ahead or behind target. You can also see all the problems you have. So it may also be a learning experience. But this is the way we use Jenkins with OpenShift. If you haven't already, when you start out, there will not be a Jenkins gear running, so you need to create that. That's all you need to do. Once it's running, you don't do that. And then I simply associate my gear, which in this case is called Google App, with Jenkins. Now, this is a lot easier on the button. There's a button saying enable Jenkins. It does that for me. But in this case, if you like the command line, I want to put it up here. That's the command to do that. If you're creating it from scratch, you know you need Jenkins right away, you just say dash enable Jenkins and you're done. Every time you now hit the Git push, it actually pushes and starts, it actually starts the build process in Jenkins, and Jenkins runs the build. It doesn't happen in Jenkins. You didn't have to do anything else. Jenkins automatically gets involved.
Question.
Yes?
So is Jenkins a quality control system, or is it a project management system, or both?
It's a build manager. It's really not a project control. You still probably need something with your milestones and all that. But what Jenkins can do is to execute all the build automation stuff that you have available. So you can go and run all the testing that you've already set up. It can verify that your source code is compliant with your standards. And the simple things that you comment, that you document everything you need to do. Are there any known vulnerabilities in your code? Did you make common code errors? And you can highlight those as, I know this is not the right way to code. This is not the standard. Did you get right? Does it look nice? Did you comment your git push correct? All that stuff can be verified by the build.
It's a continuous integration system.
Yes, continuous integration can also be used with continuous deployment. But yes, it's basically CI.
Is that based on language standards, or is it based on what your project sets up as?
So it uses, so again, the gear builds regardless of language. If I create a gear for PHP, it uses PHP mechanisms to build. If I do a Ruby, it uses Ruby stuff to build. So, and Jenkins knows about that.
Okay. Yeah.
So basically, all Jenkins does is say, OpenShift built this stuff with this source code, and then it uses all the specifications that cartridge has set up to build these. And I will show that too. A couple of good links up here. As was just mentioned, OpenShift.com. If I really wanted to advertise Red Hat as OpenShift.redhat.com, is where you're going to be routed to. But in essence, if you go there, sign up, start for free, don't have to install any servers, you've got it all available out there for free. If you really want to do it on your own, I like the bottom line because I've used that a lot. This one is a community base. It has a lot of cool, extra cool stuff that you won't find here to build. So both of them will take you through a build process. This one tells you to run a script, and you're done. This one is a little more complicated, but it actually gets you to touch some stuff behind the scenes that if you like to play with DNS, MongoDB, and all kinds of other cool technologies, follow this guy. Yes?
I got two really simple questions. One is to go back to your previous slide on Jenkins. Knowing what you know about what we're doing on this Internet in the Box, would you say that our project would benefit by us installing Jenkins on there as kind of a management system?
You're not really building code. You have content, right? So your idea is to publish content. Now, can you tweak Jenkins to verify that all those prerequisites for running those are being fulfilled? Sure. But it's not a software build per se. So it is a little bit outside Jenkins' comfort zone.
Yeah.
There are other tools out there, I know, from WordPress and so on, that can verify that things are correct, that the consistency of information in the database corresponds with everything else.
Okay. The other question is, probably everybody already knows the answer to this, but so you build this cool app, and then you're going to put it out there, it's going to make it a web, whatever. And you choose to use Python or PHP or whatever you're going to use to run it, okay? And then what guarantee do you have that when they come out with an upgrade or update to one of those programs, Python and PHP, and you built this cool app, that update's not going to totally obliterate your cool project?
Well, because the update will not be applied to your cartridge. So this is what we go a little bit into the Docker world eventually. That's going to make it even more clear that you are in control of that process. But remember, I had like 5.4 and PHP as a version.
Yeah.
Let's say 6.0 PHP comes out. Well, it doesn't change. You're running on 5.4.
Oh, okay.
Right. So that will be a separate cartridge. So you are now responsible for basically say a snapshot of your code, create a new gear for 6.0, and try it out and see does everything still work and when you make adjustments.
So if you upgrade to 6.0, you might have a problem.
Well, that's always going to be the case, right? If the 6.0 breaks backwards compatibility, which sometimes happens,
Yeah, right.
then you will need to adjust this, but it won't happen on what already is running.
Right.
So the standard workflow for something like this, more to Envy, or to his question, be create another instance with these gears, push a test branch up there,
Yeah.
and then run
Yeah,
it.
absolutely.
Right. Separate.
Yeah, keep them separate. That way you still need to think, you're the developer, you're the one that can really tell what is working and what's not working, and even better, you know what to fix. The applicant can't tell you that. All the applicant can say is, it failed, right? And you go, oh, what did you say? I don't know. So, cartridges. I really didn't plan on going into details with building cartridges. That's really a long subject by itself. In this presentation, I'm definitely going to make sure it's available. This link goes, as you can probably recognize, it's the same link that I showed for the community. It has a long guide that takes you through what the cartridge, how the specs work, and how to build it. But the idea of a cartridge is like a plug-in to any other platform. The idea is that this is the way additional features, can be a simple thing as, hey, I want to customize the cartridge already out there for PHP. I want it to build in a different way than what Red Hat came up with. So you go in, make your own customization, deploy that, and you're done. It could also be that, hey, I've got this very spec. I want to make COBOL work, no one else make COBOL work. Sorry to say, someone actually did, but that's it doesn't matter. Well, if you have a specialized need, you just create a cartridge from scratch that specifies, well, this is the environment that I want, and set it up in the cartridge. So this is a way of extending the framework. And what we would like to see happen, and it happens a lot actually, is that those contributions go back, just like plugins are publicized elsewhere. Cartridges are also publicized, that whatever idea you have, put it out there, and other people can install it and use it. So we got here a little longer than I thought, so I need to adjust my time a little bit, but this is okay. I'm going to make my screen flash a couple of times because I'm not going to make sure you see what I see. Just a moment. Work for you? Good. Wow, look at that technology. So I cheated a bit because I have a VM that I do all this for. And the reason I do that is because OpenShift works with DNS. I mean, I'm creating new servers all the time, and they all have unique DNS names. Instead of messing with my own workstation and destroying everything else running, I messed up with a VM instead. But of course, I can do this from a connection, right? Then we log on to this little guy. And everyone can still see that? I hope it was, from what I can see in my backend here, it was fine. So let me go up, just log on. So what you have seen so far is just the command line. There's a nice website to this too. Let me show you a little bit about how that works first. That sounds funny, whatever it is. So this is where having prepared should help. Will come in. I just rebooted the VM, so hopefully it doesn't do that. Wow. Did you say something? So this is not cool if it doesn't like me.
Peter, is that your preferred way of working locally? VMs, cheaper, install OpenShift, like natively?
I do a lot of demos, and the only way I can make sure that one demo doesn't interfere with another is VMs. Now with RHEL 7, and once I get everything converted over, I may start using Docker more and make sure that I can actually control it that way. But in essence, I don't like the idea of having everything on a big box that competes with one another. So is this server still running? Did I change the security setting for this demo? I don't mess up my desktop. And just to make sure that I get things running here, I'm going to stop service again.
I'm going to check your VGA cable.
Let's try to screw it in here.
What do you need to install locally? Nice. So locally, you would need the RHC tools.
Yes.
So that effectively, knows how to speak the language between what you're doing locally and the OpenShift instance.
So IFC, or the Red Hat file, or whatever you want to say that release comes from, is a Ruby gem. So you don't even need anyone with a Ruby install on their workstation to do a Ruby gem install IFC and set. That's all you need. For command line. You can try again.
Everything you're doing, though, you could do via online, OpenShift online, right?
Yes.
And then
Just
some,
one
yes.
step.
So see, now it works. I don't know why I had to restart it, but I did it. Yeah, woo. I don't know what it is, but when my KVM, when I hibernate my machine, all the network gets screwed up, and I cannot figure out what it is, but I learned that every time I sync my box, I have to restart them all. One day I'm going to find out if I can't figure out what to say anyway. So I sign on to my account. Now, OpenShift Online is going to look a little bit different before I get to this point, because there's a lot more welcome to and explaining of what OpenShift is on a public page that doesn't require login. OpenShift, when we go to original, I know this is enterprise, and I ran out of time. I could not get enough time now to install original. That should be the case next week. Okay. Because we don't need the, let me explain or let me try to turn on to OpenShift before you get here. This is standard HTTP of a digest actually. So by the time I get to the site, I'm just using the password and I go straight into OpenShift. But once you log on and you go to the actual My Ears, you're going to look exactly like this on OpenShift. So this is showing me I've already got stuff running. And there's a couple of things that I have mentioned before. We have the concept of a domain. And as you see, we have several years already existing, but a domain is simply a way of naming things. So it's a way of separating my namespace from someone else's namespace, or my project namespace from another project namespace. So everything I do has to have a name. So the year name plus domain name is unique. So I can't have two years called the same, and I can't have two domains called the same. So in this case here, I have 4 years already done, and what I'm going to do is I'm actually going to access this PHP a little bit. Just to make sure I don't too much. I just deleted the server. It's gone. I have a full server running with all kinds of code. It's no longer present. That's the time. Now, if I want to do application in here, I click the add. I'm now given a menu of all the different cartridges that it knows about. If you're going with original, this list is a lot longer than I can install it. So I mean, this is why I'm a little sad I don't have that with me right now. So this is just what's in the enterprise edition. Community is always way ahead and has all kinds of ideas that we haven't, as a company, decided on yet. So what's going to take it? Let's say I want to do something other than PHP. Let's say so here's a Python cartridge. All I need to do is give it a name. And it's gently suggests calling it Python, and it's really going to happen. So let's call it Colab. So what this is telling me is I get a name, this is the domain I'm in, and this is the domain OpenShift is installed. In this case, I have very limited access. I have access to only one size each, and so I'm not getting a choice. I can create an installation that's too small, so you can't take anything. With some, if you have the need, you can apply for it, and so if you're a contributor, you can get additional space. In this case is memory, CPU, and disk. All go together. So in this case, small means 512K of mixer of RAM, 1 gig of disk, and about a core of processing power. All that is controlled by CPUs, what is allotted to you. There's also another little guy here that I haven't even mentioned before. So one of the cool things about OpenShift is that once you have your things deployed, it can actually deal with, hey, you made the best app since sliced bread, and people are just hammering that you need additional resources. So if you go on your own server and start over, you now need to scramble, set up a new server, duplicate it. It'll take a while. With OpenShift, because you have a resource pool behind it, it just scales within that pool, and you're getting more and more automatically. It will add more and more resources to your app by adding additional gears on demand. They'll balance between them, and you will deal with that extra search of things, and then when your usage goes down, it will start scaling back. All within without doing any coding. All I need to do is put on the scaling. Yeah. There's an additional option that in the installation is not there. I can also do high availability. And within that realm, it means no matter what fails, if I take down a node, my app is still going to fail. So we know single point of failure. All that is solved for you. But it's not solved for you. If your application has to be aware, let's say it's a stateful session, I don't know how many is aware of what that means, but use a shopping cart as an example. You're making a shopping application, and as you go through, you're adding things to your cart. That cart is a session that is kept on for each of your click, because for a normal web server, you're only alive as long as that click is being responded to. Once it's done responding, you're gone. But by stateful, we ask it to remember something between each click, like a shopping cart. And because you have a session, that means it's associated with your browser. It's how we got cookies in the first place. Now session IDs, that's actually true. By being able to fill a lot of times that shopping cart is just in memory. It's not being put to disk and everyone will be using disk. We have built clustering features in our coding that needs to be done. That still needs to be done. OpenShift has not changed that. So if you need to have that, you need to enable that feature. In Java, you just put distributable into your deployment profile. In most cases, that's all you've done. So it's not a big deal with some languages, all languages, you just use the right libraries when you start out. Yes?
Also with scaling, say with an upgrade process, right? And you've scaled out because you got the most popular things, whatever. And now I want to be able to upgrade, say, Python, and I'm going to go out. Does it automatically remove things from the pool, upgrade this one, upgrade, or are you just going to have to take down?
If you're doing upgrades of the framework, you've got to take it all down. Or you create an additional, you create a new one and put it all like we talked about before. If you're doing of your own code deployment, when it scales, it just duplicates your gear. So if you're changing the way it does the session, maybe the stateful management, you've got to take it all down. But that's what you have to do anyway to deal with that. If it's stateless, no, just update it and it will automatically, basically just async it behind.
But any system upgrade,
yeah.
Is that required?
It will do that. We'll do a build on one box and we will async it out. No problem. So I hit the create application. And if my environment is still working, I should not be talking too long before I get a response here that it is done. Hopefully, if I am still going to be like, here we go, it's done, less than 10 seconds. I wasn't lying. I now have a full working app. Now, it is going to try to be a little nice to me and say, in case you haven't done this before, here's the instructions of how to go on. I did this in a browser. So there's nothing on my file system right now that reflects this project, which is where I would do. So it is telling me, oh, by the way, if you want to clone this project, which you most likely want to do, this is the command to do. It also goes down here to say, if you have used Git before, here's the commands to use Git. It's just helping you out. Let me go, okay, I know all that stuff. Let me go to the application page where my gear is. So this is the management of my gear. Up here is actually the URL to my application. Let me just open up that in a different link. Here's my application running. This is my welcome page. Hello world. It's a static page with pretty much the same information that we saw before, but this is actually in my gear. So once I go in and I'll show you, I can actually change this code. Yes?
Just a quick question. Aside from Git, there was mention on the RHC setup thing. Does that mean that this should be originally be started with a Red Hat system, or is any Linux GitHub system type setup?
This does not require Red Hat. The only thing that really, I would say, can be your a trouble ticket or whatever you want to call it, but not using Red Hat is the repositories where all the OpenShift code is located. By Red Hat, only maintaining out. Right? So that doesn't mean these all open source origin is on GitHub. So I should know, this is probably something I need to know before next weekend, is how that is being made available, let's say on Ubuntu. But the source code is out there, making depths out of them should not be a big deal. And just push them out that way. So this is my app, and let's go in and actually do this command here just to have a little bit of fun. So let's go to command line. And I'm going to make this bigger because I know no one can do this. And since I'm not in GNOME, I have to do this the hard way. Sorry. Okay, that's too big. Let's take 14 and see if everyone can do that. Is that good?
Yeah.
Okay. So I just created a NOVALUG directory. So the IFC command is sort of like a shortcut command for a lot of other commands. So if I don't want to remember how to do the git command, all I need to say is git clone, and I need to remember the app name, which was first demo. Okay, sorry. A super secret password. And I now have a new directory called first demo. Should have, oh, this is Python, so there's a few more files than one, but in essence, I think it is this guy here that gets executed. This is it. I'm not a Python guy, so I do recognize HTML. So let's do engage. Welcome to NOVALUG. Made a big change here. Right? Fabulous Python program, right? Okay. So first it tells me I'm an idiot because I haven't really registered my Git. So it doesn't know who I am. I probably should do that. But it tells me down here, yeah, I took the changes. I do my git push. Now, you may say, what is all this other stuff? I've never seen that happen on my git push before. Well, this is where OpenShift actually took over. And not only did I get my code up, but it actually did a whole build of my code. So this is filled up, and it's all done. The push is okay. Go back to my page, I do a refresh, and my site changed. That's the level of effort to make it one. There's no secret source, I didn't need to know how to set up a server, all I need to know is Python. I can also go one step further, and I can start using a IDE. I know most people don't like Eclipse, or at least I met several religious people that seem to have some kind of aversion against Eclipse.
You're right.
And if you don't know an IDE up front, there's so much functionality plugged into one application that even the simple things, if you don't really know how it works, can be hard to follow. And I get that. But if you ever notice how a experienced person uses an IDE and see how little work they actually do and how much that IDE does for them, you usually change your mind on, yeah, I need an IDE, and the only question is which. You should never really be looking at just using things in an editor. Even though you have syntax highlighting and so on in most editors today, that is so far from what we have. I mean, I can take my mouse, I can hover it over anything, and I get the documentation. as just one little example of what an IDE is, and this is nothing compared to all the stuff that we can pull stuff into. But what I wanted to show is that the IDE is fully integrated into my OpenShift environment. So this application here is called, it's Hello World. And it's called test 1, as you can see here. It doesn't show up down here, which is kind of funny. Figure out why that is. Oh, there it is. So I have full access to what is inside OpenShift in here. Not only that, but I can create applications, run, debug, everything on OpenShift directly as a developer. I don't need to have an application server locally at all. Now, in Java, that means I can no longer need to have a big-ass application server, libraries, and all kinds of other stuff going on. I just connect up, and I create what we call port forwarding setup, and now I can do step-by-step debug into the code, running straight in the cloud right away. I don't need to do anything. So this application here, I want to just show you this because this is a pre-set up demo. My plan is to actually run this I want to show this is an extremely small, I know it's Java, but bear with me. There is not much need to this. So this is the amount of code in Java we have. I know it looks like a lot. This is a very simple web service. And all this web service does is return hello world on the screen. I can show you that by doing this. There we go. Wow, okay? Very fabulous web service, right? It doesn't do much. But what is extra special about this application is, just to make sure there's something here with some. So in Java, we sort of we cheat a little bit because web services are not really HTTP compliant from a browser's perspective. So this one cheated a bit so I can use a browser instead of having the browser come out and say, hey, I've got some crap back that I need to throw them up or nothing. It just added a little thing so you can actually see it for real. But I'm having a very simple application here. And I want to show source and principles, and this is where Jenkins comes into play. So if I go back to OpenShift, and I say, show me this basic app here that we have. Notice that not only do I have a JBoss application server going, I also have an associated database. I'm not using that. I was just in there for an example. And I'm also associated with Jenkins. So in this case here, going to Jenkins. Now, if you notice in Jenkins before, a lot of things are going to happen very soon. And I'm sorry about that. The idea is just to show some principles within development, not to make Jenkins experts. But if you notice up here, this is my Jenkins build process. And there's a nice little sun at it, which means that's fine. Okay, that was my basic app, and I'm sorry, that was not what I'm implemented. So my basic app was a very simple app that didn't do much. Let me actually go back and get my little test app, which is so I think this was actually the wrong little machine that I done. Yeah. And my test one instead. It doesn't matter. It just might hello world too. It's the same app. I go into Jenkins and I look down here on my test build. And notice instead of a sun, I have some bad files. Right? What it's telling me is that when I ran this build, there was something not working right. And that's because I associated this with this unit, what we call unit test in Java. That was actually what we looked at very early on. So this unit test here, and this is code running to test other code. What's cool about that is this can be executed on build time. So as part of any other normal developer, what I would normally do is, if I'm a developer here, I would go in here and I would say, run test units. And if I was nice, I would tell my boss that, hey, you know, something is not running right. After we post that nice and neatly, it tells me it ran 2 tests and 1 of them failed. And it even shows with a little icon down here which one failed. And it shows me on the assert that it didn't get back hello her and my name. It got back hello. Right? So it tells me that you made a boo-boo and you're supposed to fix that. But I would still deploy it. How would anyone know? This might be 1 out of 1,000 tests. How would anyone know? Well, the build system is set up to do exactly that for me. So if I go in and look at it, there's a lot of stuff going on, but I'm going to go straight into the actual script that is run, just to show you what's really going on behind the scenes. So when Jenkins is involved, this script is run. And put in little human terms, you're not used to shell scripting, this may be a little bit bad, but I'm talking to administrators mostly here, so this is Bash, guys. Not a big deal, right? What it does initially is it takes a copy of all that source code that I put out in my gear and puts it into Jenkins. Jenkins then creates a local build. Basically, it runs and controls the whole build separately. And the idea with Jenkins is it can actually have all these slave boxes, so you can create this huge build environment that just slaves away with compile over and over again. You have huge projects, that's all it does, is compile, test, deploy, do testing of deployment, and report back how it went. You can schedule it to be done every hour, every day, every month, whatever. A lot of flexibility, but all it does is run these scripts basically for you. So once it's done, it's set up, and it runs a build, it then starts going in and say, okay, execute tests. Now, this is Java lingo, it's running Maven, but in essence, human way to read this abstractly is run all the tests, see what's going on, and once it's done, it then puts back that deployed, the binary version of that build, back into the gear so it gets correctly. Now, when I push my code, this is automatic one, I don't do anything. But as an administrator, as an owner of Jenkins, I can customize this to do whatever I want. But notice that the only thing that is gyration here is the Maven of how to run the tests. I actually added this manually because it had no way of knowing how I did the test up front. Some build system allows you to tag things, so when I say compile, it also tests. In this case, I just did this separately. No big deal. But gear build means run an OpenShift, define build mechanism, which is defined in cockroach. So this will be the same for Ruby, this will be the same for Python, it doesn't matter. So once this is run, lots of things happen, so I can go back in here and look at my last test results here. And now I have the same report here that I had as local developer. Not only does it do that, but it tells me what went wrong. So now I have a great stats report. Now, if I have tens of hundreds of contributors out there, this is a great way to know exactly the point of time where we are based on our tests, just from my test perspective. It also has something called checkstyle, which is a library that's very good in Java that goes in and makes sure that you're following basic programming paradigms, make sure you document your stuff, make sure you name things right, and don't get into basic trouble of particularly inexperienced Java guys. Oh, people that write Java that is in a hurry, forget to do stuff. And by going in here, I can get all those errors and all those checks that says, hey, I haven't done my correct stuff in my code. I haven't documented it right. I have made some coding errors that can get me into trouble later. And I get a stall. In this case here, it said that in this case here, this method is not a method that we can use for extensions. I mean, it's telling us that I have made a boo-boo in my program, and I didn't declare this as public or private. Right? So from a Java perspective, now I have a way of verifying that I'm actually compliant with code. It will tell you if I didn't name my variables right. If I started a local variable with a capital, which is legal, but in most cases we don't want that happening in Java. It also gives me another loop that I call tasks, which is another way of saying what else is outstanding. In Java, it's very common to things like make a comment and say to do, or I gotta get back to this later, or something in that sense to indicate that you don't have the time right now to do this stuff. But this gives you a collection of all of that, and in this case here, it found someone putting a fix me in the code that needs to say that when I do this with a trouble completing, it doesn't work. If the test is supposed to succeed, this thing needs to be fixed. I didn't fix it right now, but at least I put it in there. And now I'm getting, let's say, highlighted things. So in my build status, when I look at my project as a whole, I can now see how many errors I'm getting. So in this case here, I'm getting a little 125 marks on my code that I didn't do it right. I can see the 2 tasks that are typed to open out there. So there's one of normal priority, and there's one of high priority tasks. And down here, it shows me also on the test that one of them, and again, this is a very simple project, but it will give me a timing. So this will run every time I do a build, so I can actually see how good I'm doing over time. In nice graphs, right? It will tell me as I go forward, what is the status, and I can use this as a status report. I can publish this in my project status on my build. I can push it up to my public project management site. It says this is what we do. So this is the deal of Jenkins. I can show you what happens when I build, and it runs. We run a little bit low on time, so I'm going to fix that. If you want to see that, I can do that. If there's any other things, I will be happy to answer them, because that's pretty much it for today. Yes?
So Jenkins, I understood you in the beginning that Jenkins is something you could use outside of OpenShift if you wanted to.
Absolutely.
So Jenkins is essentially one of those build features that if you use OpenShift, it's sort of just built in, and that's there if you create your development environment in OpenShift.
It's there as an option. You don't have to use Jenkins to do it.
So if I wanted to build my own development environment outside of OpenShift, how much work is it for me to set up Jenkins?
That's a good topic for a NOVALUG talk.
Yeah.
Well, my thing is that I'm hearing more about Jenkins here than I am about OpenShift. So if your goal is to try to translate to your audience that, hey, look at this cool feature that's already built in, you don't have to spend 5 hours hooking in Jenkins, it's just done.
Yeah, so I'm still getting the build with OpenShift. What Jenkins asks, though, is the ability to get a status report. It has a billion plugins. It's an old project. So you can add all kinds of verification checks and other stuff that makes it possible for you to follow in a large project what's going on. If I'm just starting out coding and starting this from scratch, I may not need Jenkins for a while. Because if I'm a single developer, as you saw, I can do all this locally. I can check my code, I can verify. All that is my ID. So this is more, I would say, as a project management tool. Anything else that I can see what's going on. It also allows me to say, okay, if I want to go production or this release it 2 weeks from now, how close am I to doing that?
I think in answer to your question, by the way, I wouldn't stand up a Jenkins server, because you could go to OpenShift and say, if I know I need a Jenkins server and I want it to do something, go to OpenShift, tell it create the cartridge, or tell it to start and open a Jenkins cartridge, and you've got one running, and then you just go to the web page on it and configure it to
Yeah, just add it. You can also do post file. So it's not required. It's very optional. You can even have each user can choose.
Yeah, get all that. I'm not trying to say thumbs up or thumbs down for Jenkins. That's the point. This is a practice talk for you next week.
Yeah.
And what I'm trying to tell you is that it sounds like a Jenkins talk, not an OpenShift talk. So if your point is to try to explain why this one module within OpenShift makes it OpenShift an attractive product, then that's okay, and do that. Because I don't know about Jenkins and how much work it is. Because to me, I think you're trying to say, look, OpenShift does all this for you automatically, so you have this build environment that's just boom, you hit a button and it's done. 10 seconds, she said. So if Jenkins is really hard to set up, then it makes sense for me to go to OpenShift to create a controlled environment, because I don't want to spend 5 hours.
No, so those containers, you still need to have the server environment. You still need to have the environment to run this stuff in. All Jenkins does is compile.
Okay, then don't talk so much about Jenkins,
Okay?
is my suggestion, because it doesn't sound like that's really the appeal for OpenShift. There are other things that are going on in OpenShift that would take me hours as a developer to do.
Okay?
Right?
Something that's a little more multi-tiered would probably be really useful, like standing up a Drupal website, where you have to build out a MySQL database, that's one tier, you build out the PHP container, that's another one, and then maybe a front-end load balancer, or show that the load balancing works by.
Yeah, I'd like to see a
Video,
graph actually, if you did all these things that the gear is doing in 10 seconds, or you're building this container in 10 seconds, all the things that you would have to do on your own, and how long each of those would take.
Okay, and as I mentioned earlier, okay, so I thought, so individually it's very different, but a lot of times we're talking about a process, and a process can be hampered by other finances and knowledge. And in some cases, that process is very red tape based, and because of that, everyone needs to agree because it does cost money to run actually. And then a lot of time, that is actually what delaying is. Not only that, but if I'm doing deployment in an enterprise, I can't, as a developer, say that this is the way things need to run. I mean, I can't say, well, I want to run my app with the, running my own little security implementation that is only good text and passwords and so on. Most administrators and most security folks that are, they will say, no, you've got to fix that. OpenShift fixes that for them. So I did mention a term here called DevOps, because I'm trying to keep this out of the marketing mumbo jumbo and from a.
No, you should definitely talk about DevOps, because this is entirely about DevOps.
It is absolutely, from a product perspective, from the reason why this product makes sense, it does not only make sense for developers, it makes a heck of a lot more sense on the ops side too. This is an implementation that makes it better for both sides. And it allows us to enforce rules and regulations of how environments need to work without hampering the developers. Because the developers really don't, in the end, someone wants a login screen. Okay, I can make a login screen 50 different ways. As long as it's there, they're happy. Or if you can tell me what you want me to do, I will do that. They don't really care always of how that needs to be.
Yeah, I got that actually from your talk, even not being a developer. I understood that all these resources may not only be limiting, but they may make it impossible to do from a security standpoint, like you said. But maybe another way to show this would be, it's so easy and so quick to create these developing environments. Maybe you can create 10 different developing environments in 2 minutes. To say, okay, I've just created developing environments for my entire staff in 2 minutes.
We can do that, sure.
Just to me, the draw, and the reason I wanted to hear this, just FYI, is like for things like what he's talking about, Drupal, right? Well, I can go to, say I have, a couple things hosted in Greece or whatever right now, right now to do a plug for any web hosting, I can go do like Delicious or whatever, right? And set up my MySQL and my Drupal like this, right? WordPress like this. What interests me about this is that, like Python 3.3, for example, that's not going to be available on a lot of the web servers. Any kind of reasonable new Perl, right? I don't have a GCC compiler, so I can't do things like Modulicious. I can't do things like Sinatra. I can't do things like, on a lot of those basic, Bluehost, Greenpeace, what have you, right? And you can with this. And so I probably would emphasize that, because that's easy. And I'd also be interested in knowing what you think the differences are in terms of ease to deploy for things like WordPress, what have you, if you're doing that sort of stuff.
So isn't there like a Drupal container template that you can just kind of say, I need Drupal, just.
So there's a
I don't care what you have to do, make
peers or different packages, like, I'm trying to remember what the official word is. On OpenShift Online, there is a set of easy started specs. So if you want a WordPress site, you don't have to first say install PHP, upload my WordPress and all of that. There's basically create my gear as a WordPress, and it automatically puts on the WordPress code, sets up the database, and when you log in, you read carefully the guide and tell you what the password is. It won't be on the initial screen, not that dumb, but it's easy to find. And you log on and you'll have a functional WordPress site or Drupal site. So there are recipes like that that are always set up for more a end-user application or focus versus a developer focus, because now I just set up an app to create something. So one of my sales guys just told me the other day, he had a mother-in-law that's not very IT savvy. They can't figure out how to show pictures from their vacations and so on. And he finally went out and opened up, created a WordPress site on OpenShift.com and put the pictures on there. And in 10 minutes, guided his mom-in-law into that. And they could watch the because he said they can't figure out Flip. Like, stuff that, but it was that simple. And the guy's not technical by no means. But he could use OpenShift to do that. He didn't have to figure out how to go to hosting guides and figure out. Now I know that hosting guides that says something.
You can migrate it out too after you test it in there.
Absolutely. So again, remember, there's a GitHub behind the scene here. So you have all your source code, right? Now, if you look at WordPress, there's a database and all that stuff. The database is accessible to you. So if you want to do an export of the data, you can log onto the SSH here and do that there, or you can do what between one OpenShift installation to another. You can do a snapshot and take that image and move it over to another place and import the snapshot. You're done. And you move it from one installation to another within OpenShift. But this is all source code based, right? So once you have your source code in one place, you can move it to another. Now, if you move it outside OpenShift, remember OpenShift depends on all those templated specifications. So that will be, well, you are allowed to use these versions of these libraries. You automatically put that. So, for instance, for the Java app, it will go in and find the dependencies, and you can limit those. You can say, only download from this repository. That's the only repository code that we have declared legal in our organization on my project. And if you try to go beyond that, you won't find it, won't build it. Or vice versa, when you take what you build, go somewhere else, and then you have different requirements, and things may not work the same way. And that is I saw that, thanks. And that's the DevOps part of it, that the guys that are responsible for making things running, not breaking, can now help you not get into trouble by the time you need to go with it. In open source projects, that may not be a problem. So that's about it. I need to cut down time. I thought I actually did that already, but I need to cut some more time on this. So, I appreciate you guys for showing up.
Thank you very much.